Okay, good morning, everyone. Today, we will continue to the next chapter of the fluid and particle mechanics. And today we will discuss about the fluid static. And basically, the definition of a static fluid is when the fluid in the state of not moving, right? So the fluid is said to be static or to be at rest if there is no shearing force that act on the fluid, because we already know that the cause of the moving fluid or the fluid can be said moving or experience continuous deformation if the fluids experience shearing force. So if there is no shearing force that act on the fluids, then the fluid will be remaining in the static condition. And if the fluid are in a static conditions, it means the fluid will be confined in a certain volume by a solid wall. So there will be what we call a container or the boundary volume of the fluid. The fluid will have a certain volume and it will be contained in the solid wall. In a static fluid, the parameters or properties that affected or experienced by the fluid is pressure. So you please remember that pressure is force divided by the area. It means in a static fluid, pressure will be force that given by the fluid perpendicular to the area. What kind of area? This is the area of the wall. So how to calculate the pressure? It means just divide the force from the fluid divided by the area of the wall of the solid wall that's perpendicular to the direction of the force. Or pressure is the ratio between the acting force by fluid, which is perpendicular to the working area and unit area. So the unit of the pressure will be the unit of force divided by unit of area. For the standard unit, this is the standard unit, the unit of the force will, the unit of pressure will be Pascal. Pascal is the same as Newton, because the Newton is the unit of the force, and cubic square meters is the unit of area. Or if you convert again, Newton will be mass time gravitation. You can also say that this one, right? So this one will be this one. So Newton will equals to kilograms times meters divided by square second. So Newton will be kilogram, not Newton, sorry. Pascal will be kilogram mass per square second divided by square meters. This one. So the unit should be similar. This is all the standard unit. Beside the standard unit, you may find the pressure in other unit. For example, bar. Normally, you can find this unit of pressure in the cylinder. So 1 bar is equals 10 to the power of 5 Pascal. It means 100,000 Pascal, right? Sorry, 100,000 Pascal. Or if you convert into megapascal, become 0.1. If you convert into kilopascal, become 100 kilopascal. Other units used in pressure is also ATM. ATM, normally we use it to state the condition of the pressure in the environment. So like in the open space or the open area, we call it like atmospheric pressure. So 1 atmospheric pressure will equals to almost similar to 1 bar, but a bit more, like 101,325 Pascal. Okay, the others, maybe you may find the unit of the pressure is in other standard, like in British, you may find that the unit of pressure is 1 kilogram force divided by square centimeters. So this is some units of pressure that we will commonly found in some application. Okay, related to pressure, we can classify as what you call absolute pressure and gauge pressure. Absolute pressure represents the total actual pressure of the system at the certain position. Ya, jadi tekanan absolut itu menyatakan tekanan total yang sebenarnya dari suatu sistem pada posisi ketinggian tertentu. So the absolute pressure will be actual total pressure of system at certain position and height. Okay, different from absolute pressure, sometimes we find what we call gauge pressure. So gauge pressure, is actually the device that used to measure the pressure of the system. But commonly or usually, the pressure measuring device calculate the pressure of the system by taking the differences between the actual pressure and the atmospheric pressure. Ya, jadi alat ukur tekanan itu biasanya mengukur tekanan suatu sistem dengan cara membandingkan antara tekanan sistem itu yang sebenarnya, tekanan absolutnya, dibandingkan dengan tekanan atmosferik udara luar. So the pressure measurement device calculate the system pressure by subtracting the actual total pressure of the system, the absolute pressure, minus the atmospheric pressure. So the gauge pressure will be the difference between absolute pressure and local atmospheric pressure. So please be careful. If you find in some problems, in some soal, which one is the pressure? Is it the absolute pressure or is it the gauge pressure? The calculation or all the formula that we will use in fluid mechanics is usually using absolute pressure. So if you find the formula like pressure times some other parameters or divided some other parameters, the pressure stated is absolute pressure. So if you find the pressure is the value that you got from the pressure measuring device, it means it's the gauge pressure. Ada pertanyaan dulu sampai di sini? Any question?
Sir, I have a question, sir.
Okay.
What's the PVAC, sir?
Oh, later. We will discuss it later. I'll give you the example after this. Okay, so basically you can understand what is the difference between absolute and gauge pressure. Absolute is the actual pressure. The gauge is the differences between the actual and the local atmospheric pressure. Okay, now I give you example.
Sir, I have another question, sir.
Yeah, okay.
Why do we need to find the difference between the actual pressure and the atmospheric pressure, sir?
It's not that we need to find the difference, but the mechanism of pressure calculating device or pressure measurement device is by doing that, because that device itself cannot measure the absolute pressure. There are some devices that can use to calculate the absolute pressure, but most of the device just can calculate the differences. Jadi bukan kenapa kita harus menghitung selisihnya, bukan, tapi memang keterbatasan alat itu hanya bisa mengukur bedanya saja. Walaupun ada alat yang memang bisa mengukur tekanan total. Oke?
Oke.
Okay, now I give you one example. Suppose you are in a certain location, and then you have sistem silinder. Ya, jadi Anda berada pada ketinggian tertentu, Anda punya sebuah silinder. The system is the cylinder, and then the cylinder is open. So the content of the cylinder, the gas inside the cylinder, for example, the air, is connected to the air outside the cylinder. Okay. How much is the pressure inside the cylinder if the cylinder is in open condition? Kalau ada silinder, Anda berada pada posisi tertentu ya, pada ketinggian tertentu di atas permukaan tanah gitu. Anda punya silinder, silindernya terbuka, udara yang di dalam silinder terhubung dengan udara yang di luar silinder. Berapa tekanan udara di dalam silinder? How much is the pressure inside the cylinder? Anyone can answer?
Sir, if it's the pressure inside the cylinder, then it will be different all throughout the cylinder, right, sir?
Now the cylinder is open to the air.
Sir, will it be the atmospheric pressure? I'm not sure though.
Okay, why you have opinion that the pressure inside the cylinder, which is open to the air, is the atmospheric pressure?
Because it's opened?
Yeah.
I'm
Actually,
not so sure.
yeah, it's correct. It's correct. So if the system, the cylinder is open, it means it's connected to the outside environment. Then the pressure in the cylinder, in the system, will be the same as the pressure outside the cylinder. And the value will be the atmospheric pressure. This one. Ya, jadi kalau tangkinya, sistemnya kan tangki. Kalau tangkinya itu terbuka ke udara luar, maka tekanan di dalam tangki itu akan sama dengan tekanan udara luar. So any open system, open tank, the pressure will be the same as the atmospheric local pressure, or we call it PATM.
Sir, I have a question, sir.
Sure.
Apa bedanya this one, sir? The ATM, the P by the atmospheric pressure when it's open, sama rho GH kalau misalnya itu, sir, kayak pressure biasa kalau misalnya di kidas makan apa? Kalau misalnya it's in the bottom, the pressure will be different sama the one it will be on the top because of the difference in height gitu, sir. Sir, misalnya kayak gitu, you know.
That's the hydrostatic pressure. We will discuss it in the later discussion. Actually, the concept is similar. But here, we learn a more simple situation. We just considered the tank is maybe is not that big, right? So if you just open the tank, open to the air, it means inside the tank, the pressure will be the same as outside the tank. And how much is the pressure is similar, is equal to the atmospheric pressure. Later, we will discuss that the value will be influenced by the height. Later.
Sir, jadi ini tuh cuman kayak ngelihat permukaan airnya itu, sir. The pressure
Actually,
done by the surface of the water.
Yeah, you can consider like that. But here, we just fill the tank with air. So this will be air. This one is also air. So there is no water inside the tank. So you just can say that any point inside the open tank, which filled with air, the pressure is the same, right? And it's the same with the pressure outside the tank.
Iya benar, sir.
Okay. Now, how much is the value of the atmospheric pressure? Is it always 1 atm?
I think so.
It depends on how high you are.
Yes. Actually, the value of the atmospheric pressure is not always 1 atm. It will be depend on the position of the system. For example, if you put the tank or if the surface of the Earth is at the same height as the sea level, right? Sea level, then the value of the atmospheric pressure is 1 atm. So 1 atm is the value of the atmospheric pressure when the position of the system is at the same height as the sea level. Ya, jadi nilai tekanan atmosferik itu tidak selalu 1 atm. Tergantung pada ketinggian tempatnya. Sistem itu ada pada ketinggian berapa? Relatif terhadap permukaan air laut. Kalau permukaan air laut itu, kalau ketinggian permukaan itu sama dengan permukaan air laut, maka tekanannya 1 atm. It means if the place here, contoh ini ya, for this example, if the place in the sea level, it means inside is 1 atm, outside is also 1 atm. Because the system, the tank, is in open condition. Okay, now the second problem is you close the tank and then you compress the air inside the tank by using compressor. Compressor is the device, later we will discuss in detail, to increase the pressure of the gas. Okay. If you put compressor to increase the pressure of the air inside the tank is already closed. You need to close the tank in order to increase the pressure inside the air. Kalau Anda buka, if you open, then you put compressor, it will not increase. So after you close the tank, you close the system, you use compressor to increase the air pressure inside the tank, then the air pressure will be higher than the outside atmospheric pressure. Correct, right? Ya, jadi kalau Anda menggunakan kompresor, tangkinya ditutup, terus dikompresi, maka tekanan udara di dalam tangki yang semula sama dengan udara luar naik. Sehingga setelah kompresi, tekanan udara di dalam tangki akan lebih tinggi daripada di luar tangki. For example, it will increase to this position. How much the value? Maybe 2 atm or 3 atm, for example. 3 atm. Since the initial pressure will be 1 atm or atmospheric pressure, then if you increase by compression to this point, then the absolute pressure inside the tank will be this value, right? This value. This is the absolute pressure value of the tank, which is already compressed. How much is the value of the absolute pressure? 3 atm. Okay, now the tank is already compressed, still in the closed position, and then you put or you measure the pressure inside the tank by using pressure gauge. It means the pressure gauge is only take the value by differentiating the pressure actual inside the tank minus the pressure outside the tank, which is the atmospheric pressure. So the value that measured by the pressure gauge will be this one. How much is the value? 2 atm. Karena tekanan absolut di dalam, because the absolute pressure inside the tank is 3 atm, and pressure outside the tank is 1 atm. So the differences will be 2 atm. That's why the pressure gauge of the pressure measuring device is absolute pressure minus atmospheric pressure. Ada pertanyaan dulu sampai di sini?
Sir, kalau diganti water bedanya apa sih?
Oh, later. Because we will have hydrostatic pressure. Later. Sabar, oke? Okay?
Oke, sir. Tapi kalau misalnya dibuka, sir, sama aja kalau misalnya water or air?
At the top of the water, which in contact with air, it will be the same.
Okay. Thank you,
But
sir.
inside the water, it will be different.
Okay, I understand, sir. Thank you.
Okay, now, after air is being compressed and in the closed system, you open the system again. It means the air inside the tank is in contact with air outside the tank, and the pressure will come back to the atmosphere.